Good morning, children. This is the second part of the chapter. That is the link for the second part of the video I'll send you. This part will start from desirable and undesirable changes. As I told you, this is the last two lines in page 4 it is written. So take out page 4 only. Now, desirable and undesirable changes, from here we will start. Desirable changes, some of the changes that takes place which are useful for us. Some changes, these changes are useful for us. We want that change to occur, okay, because it is useful for us. For example, I have written ripening of fruits. Now, the ripe fruits, the raw fruits we cannot eat. The ripe fruits only we can eat. So we want that change. There is a change. From raw fruits we are getting the ripe fruits. So there is a change. And the ripe fruits only useful for us because we can eat that fruit. And sometimes raw fruits also we are eating. It is not that we are not taking the raw mango we are eating. Okay. But ripe fruits, some fruits without ripening we cannot eat those fruits. So ripening of fruit is also a desirable, it's a desirable change. We want that change. Digestion of food. We are eating food. Now we all want it to be digested. Otherwise, if it will not digest, then we will not get energy, and that is not good also, isn't it? We want whatever we are eating, it should digest. After digestion, some other thing is forming. Food is no more remain in our stomach. So we all want the food to be digested. So digestion of food is, there is a change because some new thing is forming, and it is useful for us. So it is a desirable change. Now, getting promotion in class. This year you are in standard 7. Last year you were in standard 6. So there is a change. You will not go to standard 6 again, and you will not sit in that class, and you will not go through the syllabus what the standard 6 children are studying. So there is a change, and that change you want. That is a desirable change. So all these are the example of desirable change. Is it okay? Now, undesirable changes. Some changes that are not useful to us. The changes are happening, changes are occurring which are not useful to us. We don't want that changes. Like earthquake. Earthquake is a change. There is a change when earthquake occurs. But earthquake, we don't want earthquake because it is destroying the places. It is creating a problem. We don't want earthquake. So it is an undesirable change. Burning of forest is undesirable change. Injury, that is fracture of bone. Suppose you are getting your bone is fractured. You fracture your bone. Now it is an injury that you are getting. So it hurt you. We don't want that change, isn't it? So these all are undesirable change. The changes, there is a change when there is a fracture, but we don't want that change. So it is an undesirable change. Next is your exothermic and endothermic change. This exothermic and endothermic change, when I was discussing heat with chemical change, heat portion, that is the characteristics of chemical change, the last point, heat, I was just talking to you about it. So it is something related to that, exothermic and endothermic change. Exothermic changes means, as I told you, that the change in which heat is released, heat is evolved, heat is going away, heat is going out, all these things, these things are happening. This is known as, when these things are happening, heat is released or heat is evolved, this is known as exothermic change. Like burning of paper. When you are burning a paper, as I told you, if you are burning a paper, then heat is coming out. You cannot touch that, isn't it? Why you cannot touch that? Because you are feeling hot. Why hot? Why you are feeling hot? Because the heat is coming out, heat is released. Reaction of quicklime with water. As I told you that I will tell you this reaction, this example. Quicklime means that you must have seen whitewashing. The people are doing whitewashing. Okay, simple whitewashing. What they're doing, they're taking a white thing and they're just dissolving it in a bucket which contain water. That is known as quicklime. That white thing is known as quicklime. In Hindi, we are calling quicklime as chuna. When we are dissolving quicklime in water, then some reaction is going on. And you will see some effervescence is occurring. You can see some effervescence there. Effervescence means bubble formation. Formation of the bubble. And that means what? That means some reaction is going on. Because of the reaction, when quicklime react with water, it is giving you lime water. And with that lime water only, they are just doing the whitewashing. Now, when this bubble is coming out, when this effervescence is occurring, at that time, the reaction is going on. At that time, you touch the upper part of the bucket. Okay? And you will find that the bucket is becoming hot. That means what? Because of the reaction that is taking place inside the bucket, that is the lime and the water, heat is evolved. And because of the heat evolved, the bucket is becoming hot. Okay, so this is an example of exothermic reaction. Candle flame. You cannot touch the candle flame, isn't it? So it is an example of exothermic reaction. Endothermic reaction. Endothermic reaction means the change in which heat is absorbed. Some of the reactions are there where heat is absorbed. Melting of ice cubes. Now you are taking the ice in a bowl and then allow it to melt. And then you touch the bowl, you'll feel the bowl is becoming cold. Why? Because of the melting of ice, what it is doing, it is taking heat. It needs heat. So it is taking heat from the surrounding. Now what is the surrounding here? Surrounding here is the bucket. From the bucket or the bowl, from there it is taking the heat. Okay, and that is why the bowl is becoming cold. When you will touch the bowl, you will feel the cooler sensation. As I told you that you just put some glucose on your tongue and you will feel a cooler sensation in your tongue. Why? Because for the dissolution of the glucose, okay, it is just changing its state. Dissolution of the glucose, what will happen? It is taking heat from the tongue. Okay, and you are feeling a cooler sensation. Am I clear, children? So these are the example of exothermic and endothermic change, and I think now exothermic and endothermic change is clear to you. Now in this I just want to tell you something. Children, please take out book page number 13. I'm just waiting for 1 second. Please take out page number 13 in your book. I hope you have taken it out. Now in book page number 13, see the example of exothermic change. Example of exothermic change. Here the example of exothermic change is given as photosynthesis and evaporation of water. Okay. Now I just want to tell you here, photosynthesis is a process, that is the green plant is making their food. You all know about it. So for that, preparation of their food, green plants require 2-3 things. What are the things? One is chlorophyll should be present, the green pigment present in the leaves, that is the chlorophyll, and it requires your carbon dioxide, it requires sunlight. All these things are required. Now what is happening? They are getting carbon dioxide from the atmosphere and they are taking sunlight. That means it is absorbing sunlight. That means it is absorbing heat. That is the energy it is taking. It is taking energy. That means taking energy, absorbing heat is endothermic. It is not exothermic. So in your book it is written in the example of exothermic, it is given wrongly, children. And another example is given, evaporation of water. Evaporation of water means it is taking the heat from the surroundings. It is taking heat from somewhere. It requires heat to evaporate. Okay, so that means it is absorbing heat. The simple example I can tell you that you are spreading your wet clothes for drying. And what is happening? It is absorbing sunlight, and then after that the water is evaporates. So these two are the example of endothermic, not exothermic. So in page number 13 it is given wrongly. Just cut it and write these two example in place of endothermic: photosynthesis and evaporation of water. Am I clear, children? Okay, these are the mistakes. Now next is coming reversible and irreversible changes. Reversible change and irreversible change, I told you this too when we are talking about the physical and chemical change. Reversible means which can be reverted back. It can be reversed back. If you are withdrawing the condition, for which condition the change is taking place, if you are withdrawing that condition, it will again go back to its original position. The example are inflating and deflating of balloons. Suppose you are pushing some air into the balloon and the balloon is inflated. Now take out that air, or allow the air to go out, then the inflated balloon will become deflating. It is deflating. So inflating and deflating of balloons is an example of reversible change. Stretching of a rubber band. You stretch a rubber band to a certain extent, then again you release it, it will again go back to its original position. Okay, so it is a reversible change. Irreversible change, the change which cannot be reversed back even if you are withdrawing the condition. As making cheese from milk. If you want to make cheese, that after forming cheese, you cannot get back milk again. Passing of time. Yesterday will never come. The time which has gone, it will never come back. So passing of time is an irreversible change. Falling of leaves from a tree. The leaves are falling from the tree. You cannot put it back again. So these all are the example of irreversible changes. Now children, take out the page number 14 in your book. Take out page number 14. Now there are two action time given. Action time 4. Let me just explain the action time 4 first. It is said that to observe that the heat energy absorbed or evolved during a chemical change. What the experiment is saying, take a porcelain dish. It is a small bowl type of thing made up of glass. Then take iron powder in that bowl and just heat it. And then put it in the Bunsen burner, in a tripod stand in the Bunsen burner, fix the apparatus and all, and then take the iron powder in the porcelain dish and add some sulfur powder to it, and then you heat that. After heating, after some times, what you will find that the mixture of iron and sulfur will turn red hot, and in the porcelain dish, and a compound, that iron and sulfur will mix together and it will give you a new compound, that is iron sulfide will form. Now what is the conclusion from this? The conclusion is that energy is either absorbed or given out during the reaction, chemical reaction. Okay, in this reaction what is happening, initially you are giving some heat. You have to heat that, otherwise the reaction will not start. You have to heat the reaction, and that is why Bunsen burner is required to heat that porcelain dish, where you have taken iron and sulfur powder. Now initially you are giving heat to that mixture, and as you are giving heat to that mixture, after some times the heat will release heat. It will release heat, and that is why it releases it as the mixture turned red, showing that a large amount of energy is released now. So first it is required some heat for this reaction. It is required some heat, and then after that it is releasing heat. Now action time 4, what it is said, to observe how energy changes when a change takes place in a substance, whether it is endothermic or exothermic. That I will tell you. What is there? What is given in this action time? Take 2 test tube, fill both the test tube with water. Okay, now in one test tube, suppose the first test tube A and the second test tube is B. Now in test tube A, you put some salt, and test tube B, you put some quicklime. Okay, now just dissolve salt in the with water and in water, and dissolve quicklime in water. So after dissolving, touch test tube A and B both. What you will find, test tube A is giving you the cooler sensation, and test tube B, when you will touch test tube B, you will find that the test tube B is becoming hot. Test tube A is cold and test tube B is hot. What is the conclusion from this you can draw? The conclusion that you can draw, the first one, the test tube A is having salt. We are dissolving salt in water. So dissolution of salt in water is an endothermic change. So it has taken heat from the test tube, from the surrounding. Surrounding here is test tube. So it is taking heat from the surrounding. So dissolution of salt in water is an endothermic change. It absorbs heat. Okay, and that is why the test tube was cold to touch. And in test tube B, where your dissolution of quicklime in water, dissolution of quicklime in water is an exothermic change, and that is why it is liberating heat, and as we are touching the test tube, we are feeling that the test tube is becoming hot. Okay, so the first one is the dissolution of salt in water is endothermic change, and dissolution of quicklime in water is exothermic change. So I think up to this much, all these 4, all the physical change, chemical change, desirable, undesirable change, exothermic, endothermic change, and reversible, irreversible change, now it is clear to you. Okay, so next part, the third part, the last part, again I will send you the link for the third video, and then the chapter will be finished. So 2 videos link I will send, and the third one also I'll send all the 3 together. And then when you will, again I'm just repeating that, when you will see the video, take out the notes with you, then it will be easy for you to understand. Till then, goodbye children.